Hi, this is Terry Denery of the MathWorks, and we're going to do a few more homework problems. So here's this kind of practice test, and so I'm going to just start off with the snipping tool, and I'll copy this in. So just kind of grab that right there. Simple beam problem. And so we'll go to MATLAB, we'll open up a live script. We'll go Control E, puts us in Talk Like a Human mode, and I'll paste that in right there, right? And, you know, basically we got a little bit of loading. I'll use this zoom in tool, do it in blue, right? And we have basically the weight of this human being. Oops, I didn't do that right. So let's try that again. So Control 2, Control and Shift together, I believe will give me an arrow where the arrow starts where I first click. All right, so this guy's got a weight acting down, but also the beam has a weight acting down. So these two weights we want to account for. All right. All right, and so I'll collect some of the data, most important data. Oops. We need to go into Talk Like a Computer mode, so I'll hit Control E again and toggle back into that. And so we'll make the assignment for G. And I want to make this a little bit bigger. It's equal to 9.8. And let's see, M student is equal to 74. I'm going to do everything in metric, so that's implied to be kilograms. And then the mass of the beam is 100. Okay. All right, so now I'm going to do the calculations on the weights. And so W student equals M student times G. And let's see, and then W beam equals M beam times G. All right, let's just hit the run button and see what those calculate to. All right, so those are weights in newtons. Again, everything's metric. All right, and this problem, let me kind of drag this over so we can see our picture, is, you know, it's a classic statics problem. In a way, it's one of the easier ones because there are really only two unknowns. And so let's get back to kind of pointing those out, and that will be the reaction force right there, which is in the y direction, and the reaction force right there. Right? And I don't want to necessarily say that there's no x forces, but they're irrelevant. You know, and there could be if somebody really kind of squeezed the beam and, you know, kind of put it in tension, but, you know, we don't care, right? And so in general, because of the placement of the person, we already know that the force on the right will be a little bit bigger than the one on the left, right? But we got to calculate it, and we have two. In general, for these two-dimensional static problems, we always have three equations. Sum of forces in the y are equal to 0. Sum of forces in the x are equal to 0, and then the sum of the moments are equal to 0. Now, x is kind of irrelevant because we don't have any relevant forces acting in that direction. And in general, I think it's a good idea to do moments first. It usually gets you kind of, I'd say, algebra simplifies a little bit. But again, you know, you do what you got to do, right? So anyways, let's kind of work on this. And if we're going to be doing moments, we need to gather a little bit more of this data. And so I'm going to put in the length of the beam is equal to 3. I'll call it the position of the student. Maybe I'll just keep that letter L in there. I'll call it L student is equal to 2. And then the location of the center of mass, of course, of the beam is very important too. And so that'll be L beam divided by 2. So I'll call that LCM is equal to L beam divided by 2. All right. And so now I'd like to go back into Talk Like a Human mode. All right. And I want to just kind of write that sum of moments equation, and they're going to be equal to 0 because it's static. And basically, F equals ma still holds. It's just that a happens to be 0. And in torques, we generally call that angular acceleration as opposed to just pure acceleration, right? But anyways, let's get those moments. And moments is all about choice, of course, too. And we could choose any point we want. And I think we would get an answer, but I'd say there's a convenient location. And that this is kind of why I say do moments first, because in general, you can choose convenient locations that will simplify your algebra. And I'd say do your moments about support 1, all right? And so if we do moments about support 1, we got this guy acting, applying a force downward. We do right-hand rule. It means my thumb, where my fingers rotate in the direction that torque would be applied, is going into the screen. And how do I know that? Well, if that support on the right wasn't there, the beam would rotate that way, right? And so, anyways, that's going to be a negative. And so I'll just call it minus W student. Oops. Times L student, and then the beam will be the same thing, so it'll be minus W underscore beam times LCM. So those are 2 components of our moments, and the third one is really that this support on the right, which I'll call F plus F2 times L beam will be equal to 0, right? And so from this, we're going to actually kind of get everything. At least we'll get some. Well, I mean, not say everything because we'll solve for the force at support 1 in a moment too, right? But let's take that and get back into talk like a computer mode, and I'll paste that in, and then I'll just kind of rearrange the equation. So we're going to basically put all this stuff on the right-hand side. So let's take all that, Control C, paste, and change the sign on these because we moved it. So we essentially added this to both sides. All right, so we got all this kind of there now. So let me delete that. And then all we got left is to divide out the L beam part. All right, so let's go Control X. Let's group the 2 terms here with parentheses. And we'll divide. And so we'll hit run, and that's what we get. All right, now that we know F2, we pretty much know everything except for this force. And so again, I'll just kind of point it out. And so that's the support right there, which I'll call F1. All right. And so we do this with sum of forces in Y direction, which will be F1 plus F2 minus W student, because he's acting in the negative direction, and minus W beam, which is also in the negative direction, and that will all be equal to 0, because again, F is equal to ma, but a is 0. All right, so that's what statics is all about. Right? And so let's just kind of take this equation and solve for the unknowns. So Control E, talk like a computer again, and let's just do our rearrangement. All right, and so I think I'll just, hopefully this is pretty clear what I'm going to do here. And so those negative terms get added to both sides, so they become positive. And solving for F1, it'll be a negative F2 that we'll subtract off. So all that's coming from that equation. And we hit run, and there's your answers right there. Okay, so anyways, find the magnitudes, forces exerted by each support. I think we got it right there. Thank you.